Okay, now we're going to cover a case where we can get some awkward outcomes following the methodology that we laid out previously. And this type of function is just such a case. We're going to get some conclusions in the steps we use that may not make sense right off the bat, but they actually do. Let's go ahead and try and graph this function. So first we're going to do what we always do, which is set x equal to 0, solve for f of 0. That gives us 6. Okay. Now what we're going to do is we're going to plug this into the quadratic formula like we always do and solve for x. This gives us x equals -3 plus or minus the square root of 9 minus 4 times 1 times 6, all divided by 2. Okay, now here's your problem. This simplifies to -3 plus or minus the square root of -15 divided by 2. So we have a negative under the radical, which is not very good because we can't generate an actual value for x. What does this mean with regard to graphing this function then? Well, if this means we don't have any x-intercepts. If x is unsolvable at y equals 0, then we don't have any x-intercepts at y equals 0. But we do know we have intercepts at y equals 6, okay? And that's where x is 0. Okay, so what we can do in this case is we can artificially move this x-axis up to y equals 6 instead of keeping it at y equals 0. So let's take this, and instead of setting it equal to 0, we set it equal to 6. That gives us x squared plus 3x plus 6 equals 6. Okay, now let's just solve for x. This gives us x squared plus 3x equals 6 minus 6. X squared plus 3x equals 0. We can factor out an x. It gives us x times x plus 3 equals 0. Then we get two values for x. X equals 0 or x equals -3. And this makes sense because at x equals 0, y equals 6. We know that, okay? This is the key though. This is the point of symmetry, directly opposite of 6. So at x equals -3, y also equals 6. Okay, you see this now? So what we have here is we have a function that comes down like this and crosses through those 2 points. In other words, these 2 points are acting like our x-axis, our x-intercepts. Now, here's the key. We need to find the axis. Where's the axis? Well, we have at x equals 0 and x equals -3. Must be right in the middle at -1.5. So then we just take 1.5, plug it back into our function. F of 1.5 equals 1.5 squared. Excuse me, -1.5, sorry. F of -1.5 equals -1.5 squared plus 3 times -1.5 plus 6. So this equals 2.25, that's going to be a negative, minus 3 times 1.5 minus 4.5 plus 6. Negative 4.5 plus 6 is 1.5. 1.5 plus 2.25 equals 3.75. So y coordinate of our vertex is at 3.75. So right about there, okay? Because negative 1.5 is our axis, negative 3.75, positive 3.75 is the y coordinate of our vertex, and this is our function graphed. Okay, let's go ahead and do one more like this. What if we have something like, let me get one out of my trusty book here. What if we have something like f of x equals x squared minus 8x plus 19, okay? So in this case, of course, step 1, f of 0 equals 19. Let me go ahead and draw our Cartesian coordinate system out here. Okay, so when x is 0, y is 19. So that point there is going to come into play somehow. Let's do our second step. Plug this into the quadratic formula. That gives us x equals 8 plus or minus square root of 64 minus 4 times 1 times 19 divided by 2. So this gives us 8 plus or minus the square root of 64. What is 4? 4 times 19 is 76. So this gives us 64 minus 76 under the radical. Okay, so we're going to get another value. This means we don't have x-intercepts. So this must be a function that is, again, U-shaped, but lying completely above the x-axis. So again, what we're going to do is we're going to move the x-axis up to 19. We're going to set our function equal to 19. That gives us x squared minus 8x plus 19 equals 19. And this means when we subtract out the 19s, that x squared minus 8x equals 0. X times x minus 8 equals 0, or x equals 8, or x equals 0. Okay, so over here at x equals 8, that is our other intercept, so to speak. So this function's going like this, then our axis is where? It's between the origin and 8, which is at 4. Okay, so we plug 4 back into our function, solve for f of 4, which equals 16 minus 4 times 8 is 32 plus 19, and this is, what is that? That is 35 minus 32, that equals 3. So right here at y equals 3, that is our vertex. So this function looks like this. Make sense? It's actually quite easy. Nothing real complicated about it. Again, you just have to, remember what you're artificially doing is you're just moving that x-axis northward and finding its point of symmetry, acting like you're finding an x coordinate.